Good morning, MacLaren. Today is Monday, September 28th. I was inspired, as I was preparing for this, to look up what happened on this day in history. And funny enough, the first thing I read up on has a connection with my morning assembly topic. So in 1924, on September 28th, two U.S. Army planes landed in Seattle, Washington, completing the first round-the-world flight. It took 175 days. So with that in mind, I want to talk to you about how airplane cabin air systems work. I've been thinking a lot about this since being on a number of flights since this pandemic began back in March. I remember the first flight I was on post-pandemic back in July. My wife and I thought to ourselves how odd it was to be fearful of such a normal, everyday occurrence such as flying. As we got onto the plane in our masks, we sat down and began thinking to ourselves, how many people were on this flight? I hope no one has COVID, because we certainly are not 6 feet apart from each other. Thankfully, we were fine, and the flights following that flight in July, we were also equally as safe. Now, this is not a pitch to you all about getting on the first flight you can, but rather an opportunity to learn how the air we breathe on an airplane is cleaned and recycled back into the cabin. The environmental control system, which is what the whole system is called, its primary job is to maintain the pressure inside of the cabin. It allows the passengers to breathe normally. The second job is to control the temperature in the cabin. This is obviously very important. Flying at a height of 35,000 feet, which is the average height of a commercial jet, the outside temperature can reach negative 60 degrees Fahrenheit. So you want the cabin sealed and heated. So the environmental control system, as you were looking at on the screen, sucks fresh air from the engines during flight and distributes it throughout the cabin. But first, it passes from the engines to the air conditioning unit. The air passing through the engines is compressed and very hot due to passing through jet engines. So the air conditioning units decompresses the air, cools it down to a comfortable temperature, and once it is cooled, the air travels to the mixing chamber. This is where fresh air is mixed with the recycled air. Once mixed, the air passes into the crown of the cabin, where it shoots out from those tiny little AC holes above your seats. That air will eventually pass through down to the floor and is sucked back out below your feet. And this goes back into the mixing chamber. Now this air, the air that passes through the cabin, is the air that passes through the world's best air filters. I promise Boeing and Airbus did not pay me to say that. The ratio from recycled air to fresh air is typically 50-50. Now, let's look at this air filter a little more closely. These air filters are called high-efficiency particulate air filters, or HEPA filters, and they're designed to provide protection against dust, fibers, and allergens, and most importantly, microbes, which include viruses and bacteria. There are 3 different filtration methods that are used in these HEPA filters. The first is called direct interception. And this is what it sounds like. This is where the particle is literally too big to pass through the filter and gets intercepted by the fibers in the filter. The second is called inertial impaction. This is where particles that are small enough to slip through the initial fiber wall of the filter are heavier than the airstream going through it, and so they will eventually impact the other fibers in the filter as it is passing through. And finally, the third method is called diffusional interception. This is how these HEPA filters are able to filter out microbes. For these very, very small particles, Brownian motion results in rapid, random movements as the particle passes through. This movement causes the particles, viruses, bacteria, to come into contact with the filter's fibers. I had to look this up as I was doing research. Brownian motion is the erratic random movement of microscopic particles in a fluid as a result of continuous bombardment from molecules. A brief note on the manufacturing process of these HEPA filters. Making these filters is like a high-tech version of paper making. It takes about 2 months to make a batch of them. So, if you find yourself on a flight sometime here in the near future, you can console yourself knowing that HEPA filters are doing their jobs. Then turn to the person next to you and tell them about diffusional interception. Have a great day, MacLaren.